Hello, welcome to another video podcast where I'm explaining another GeoGebra app that I made that I titled Evaluating Linear Patterns with Vectors. So it takes any linear pattern like this one here where the zeroth term or the y-intercept is 4 and the difference between terms is 2, so the slope is 2. So we can change those values. Change the y-intercept, just translates the pattern. Okay, we can evaluate terms. That's what this slider is for the n value. We can also type in these boxes and change values that way too. Maybe I want the difference to be -3, so I can type it in here too and change the value that way. Alright, so now the way that this app works, and first of all, before I show it, I made this app because I realized when I was teaching sequences and evaluating with rules, my students, they really couldn't comprehend why we have a rule and how to evaluate with it still. So this app, I was dinking around with some stuff, and this is what I made. It's showing this formula that starts with a constant value, which is our y-intercept. And then it shows how many times that we're applying that difference to get to the term that we're evaluating. So it's showing things like what is t of 6, depending on what the sequence is. So you can, like I just showed, you can change, the y-intercept and the difference. So now when we click on show vectors representing rule, right now we're evaluating for the 0th term, letting n be 0. So notice it's just the y-intercept distance, right? So we've got a vector showing the translation up the y-intercept value. But now what's cool is when we change solving for the first term, notice we got a couple things happening here. On the y-axis, I have the vector addition showing where we end up after we add the 0th term and then the difference a certain number of times. But also it shows how we get from point to point with the x increasing by 1, and then we go down that difference value. So notice that's a -1.5. That's exactly what that length is. So as we change the n to be 2, now we're evaluating for the second term. Notice we've got the vector addition on the y-axis, because the y-axis is just a number line. And then also we're showing the same moves except horizontally to get to the point we're evaluating. Okay, so it's kind of neat. So as we change terms or values, notice everything just stays nice and shows the evaluation. So this is kind of neat because I'd also highlight the point that we're solving for, show the n, t of n, ordered pair solution point, and the vectors that get you there. So when you click on that, there's a couple things that happen. I show the green vector, which is in relationship to the green n. So we translate over to 4, or shift over to 4, and we just go up that same value as our vector addition. Okay, so I'm just showing, here's what the rule is saying. Right, so if I show the algebra here, here's our rule in general. I color coordinated all the parameters to the variables up here. Difference, number that we're solving for in the y-intercept. Put the values in. Notice too what's cool is the term subscript that we're solving for changes as well. Get used to that. And then just show the evaluation. So the fourth term is 9, so we can get students to read this, which could be a good transition into function notation. So anyways, pretty cool app. Also, I'm just showing the y value here with the dotted line. Okay, so as we change things around, pretty cool geometry going on. Using vectors to visually argue what the rule is actually doing to make more sense with evaluating. So hope that makes sense. Enjoy the app. I'm going to make a worksheet with this, and I'll share that in an email with you too. Probably the same email you got this video. Thanks, guys.